Bond, James Bond, a book about chemical bonding by Kristen Richter. Bond, James Bond is a boy. One day while he was at home, he decided to learn about chemical bonding. His father, who was a chemist, would help him understand. What did bonding mean? What types were there? What did bonding do? And how did people use it? James decided to walk over to his father to talk about it. His father was in the lab doing an experiment. James and his father began to talk about bonding. To show the differences between the two, molecular and ionic, there was a chart. That's neat, thought James as he was looking through the chart. James's father then thought about metallic bonding. That was another type of bonding. Metallic bonds are formed by the attraction of freely floating electrons for the metal cations nearby. The attraction holds metals together and insulates the cations from each other. This type of bonding provides many physical properties of metals, such as electrical conduction. Electrical conduction are where electrons freely float in metals, which allows them to conduct electricity. Also, thermal conduction is where freely floating electrons transmit heat in addition to electricity. In addition to samples of pure metals, metal alloys form metallic bonds. Examples would be brass, steel, and stainless steel. Do you understand that? James's father asked. Yes, it makes sense. Good. Now that you get that, let me tell you about molecular bonds. Molecular bonds form when nonmetals bond to other nonmetals. Since nonmetals want to gain electricity to be happy, you see there's a rule called the octet rule. That's when the atoms need 8 valence electrons to be stable. Now back to what I was saying. They do not want to lose the electrons to another element. In order for nonmetals to bond to another nonmetal, both must share their valence electrons. James' dad then proceeded to say, when you understand molecular bonds, you can build a Lewis dot structure. Oh yay, James screamed. Let's make one, yelled James in excitement. Okay, to make a Lewis dot structure, you first determine the central atom. Because there are 2 atoms, when you determine the central atom, you then write the others on the side. Here's an example. H2O. Then you have to draw the valence electrons on each like this. Wow, these are cool, James was excited. Now we get to the fun stuff, James' dad said. We can take our Lewis dot structure and actually illustrate how molecular compounds form and how electrons are arranged around the atoms. A dashed line equals 1 pair of shared electrons. You can draw it like this. You just connect 1 valence electron from each and connect them. Then look and count the electrons. Does N2 have the 8 electrons it needs? No, responded James, puzzled. Then you have to look and see if you need to add more. A double bond is formed when the atoms share 2 pairs or 4 electrons, and a triple bond is the same thing, just with 3 pairs and 6 electrons. Wow, you're so good at this. Well, it takes some practice, but you can do it. James' dad was proud. Now let's make a VSEPR model. It's a model is used to predict the 3D shape of any molecule. In a compound, the electrostatic forces between the valence electrons of the molecule's atom causes the electron pair to be as far apart as possible from each other. Another way to draw a 3D structure of the Lewis dot structure is molecular geometry. Now I know it doesn't sound fun, but there's no math involved. You take your Lewis dot structure and count the number of bonds on the central atom. The number of bonds on the central atom, then you look at this flow chart and determine the molecular shape and its bond angle. James's dad then got an idea. He told James to wait there while he ran to the kitchen and grabbed a bag of marshmallows and some toothpicks. Here, you can use these to make a model. James stuck the toothpicks and made a perfect model of NH3. Now what's the molecular shape and bond angle? You can see this flow chart to decide. James then decided it was a pyramidal and 107 degrees exactly. James' dad was so proud. James and his dad spent the rest of the day making the marshmallow models, eating them, and bonding together. The end.